Hi everyone, and welcome back to another SolidWorks tutorial. This is a full assembly tutorial on how to model a J-bolt and a hexagonal nut and give it this screw motion. And the screw motion is just on the thread of the J-bolt. The nut moves only on the thread of the J-bolt. It doesn't exceed. So the dimensions on the J-bolt, this full height is 28, this is 8. The height of the thread is 15 millimeters. The diameter of the bolt is 2, and the radius that forms the J shape is 4. The length on this nut is 4. The hole in the nut is 2. The width of the nut is 2 also. And the draft angle, which is the angle of inclination on this face of the nut, is 45 degrees. The size of the thread for both the bolt and the nut is 2 by 0.5. The 2 is the diameter of the shaft on the bolt and the diameter of the hole in the nut. And the 0.5 is the pitch of the thread, both on the bolt and the nut. The material for the bolt and nut is polished steel. So this is very simple to do. Make sure you watch the video to the end so you know how to model this J-bolt and nut and give it the screw motion. Please subscribe if you want more tutorials in SolidWorks like this. Like this video and share it. And we can now begin. First off, we are going to create a folder that will store all our files. So the name of the folder should be J-bolt assembly. Then you open SolidWorks. So we are going to create the first part, which is the J-bolt. It should be a part file. And this takes us to the SolidWorks 3D modeling workspace. First off, we create the shaft on which the thread will be. So it will be a cylinder of diameter 2 millimeters and a length of 15 millimeters. So extruded boss base on the top plane. Circle of diameter 2. Exit. And you're extruding downwards, so reverse direction, and a length of 15 millimeters. Okay. And we can change the background to plain white, and the appearance of the material, it is polished steel. So on the appearance, metal and the steel, we go for the polished steel. Okay. Next, we create this section. So create a sketch, and the sketch should be on the right plane. So we create a guide that will be a curve, that will be the J shape, and then we sweep a circle around it. So first we get a vertical line here. Move your cursor, come back to the point. You can now draw an arc and a vertical line. Now the distance from this endpoint to the tip of the arc is 28. This is 8 and the radius is 4. And from this point to this endpoint, 28. So from this point to the end point here, 8. The radius of this arc, 4. As we can see, sketch fully defined, so exit. Now under features, swept boss base. And we use a circular profile because, as we can see, it's a circular profile through all. So the guide, click on this sketch, and the diameter is 2. Okay, so we want to merge these faces. So click on the sweep edit feature, come to options, merge tangent faces. Okay, as we can see. So the last thing is to add a thread. So we start the thread here and end on this edge here. So with the thread feature, the start point, click on this circular edge, and the end point up to selection, and then select this edge. Now on the start point, we want to add an offset so that when the thread gets to the end, it will be a perfect shape at the end. So add an offset, reverse the direction. So this is how the thread will be like. Now since this is a shaft on the bolt, we use the metric die, and the size of the thread 2 by 0.5. So in the default thread size, we don't have it here, so you can override diameter and override pitch. So 2 by 0.5. Cut thread. Okay. So this is the J bolt. Save. In your desktop, we have the J bolt assembly folder. The first part, bolt. Rebuild and save. Next, you create the nut. This is a normal hexagonal nut, very simple. So create a new part file. Extruded boss base on the top plane. So we have a hexagon, a polygon with 6 sides, and the distance from this tip to this tip is 4. And click on this line and make it vertical. Sketch fully defined. So we add the hole, a circle of diameter 2, exit. The width of the nut is 2 also. We are going to make it symmetric since we smoothing the faces here. So we just extrude via the mid plane, then we smoothing one face and mirror onto the bottom here. So end condition mid plane to distance. Okay. Make the background plain white and the appearance again polished steel. Now extruded cut on this face. So a circle, and then you make the circle tangents to the edges here. So hold Control key, click on these edges, make tangent, exit. Now flip side to cut, and the draft angle 45 degrees. Okay. Then we mirror. So click on this cut extrude and mirror. The mirror face or plane should be not the front plane, it should be the top plane, as we can see. Okay. Then we add the thread. So again with the thread feature, the start location of the thread here, and the end location here. Again, we can add offsets of, let's say, 0.5 to both edges for a smooth thread on the end points. And this is coming inside, so reverse the direction for it to go outside. And now the type of thread should be a metric tap. Since it is a hole, we use the metric tap. And the parameter of the thread, or the size of the thread, should be 2 by 0.5. cut thread and OK. So save, and the second component, nut, rebuild and save. Finally, we create the assembly. So a new file, this time an assembly file. And this is our assembly workspace. Now these parts are opened here because they are already opened here. There is no need to navigate any folder to get to them. So close. First off, I want to make the origin visible. So view origins. And then we can insert the first component. So come to insert component under assembly. And the first component is the bolt. So click and drag the mouse. Click. By default, the first component we insert is fixed. We cannot move it. So right click, float. Now we can move it. We want to fix these 2 points on top of each other. So under meet, coincidence, and click on these 2 points. Okay. So as we can see, this is the J-bolt. Now we have to fix it very well. So again under meet, parallel, and we want to meet the top plane of the assembly workspace and the top plane of the bolt. Okay. Again, we make parallel the front plane of the assembly workspace and the front plane of the bolt. Okay. So we can see fully defined assembly. And now we cannot move the J-bolt in any direction. And we disable the origin. Next, we insert the nut. So insert components, click on the nut and bring it here. The first mate we are going to add is a concentric mate because there are circular edges here. So concentric. So get an arc here. Click. And then get an arc also here. Click. Now this is moving in a normal way, but we want to give it the screw motion. So come down under mechanical meat. The screw meat is here, and the distance per revolution we want to say 5 millimeters per revolution. So per 1 revolution we want to move by 5 millimeters. And then under meat selection, we make sure the temporary axes are showing. And we select the axis of the nut and this axis of the bolt. Okay. So this is what we have. When you click on the nut and then you rotate with your mouse, you can see the nut is moving, just as a bolt and nut will move in a screw motion. But there is a problem here. You can see the nut is moving even when we exceed the thread. It is moving, so we are going to fix that. So disable the temporary axis, and then we want to give it the limit distance meet. So under advanced meet we have the limit distance. So click on it and then we select the 2 faces to get the limit distance. So we need this face of the bolt and then this face of the nut. Now we have to get the maximum value and the minimum value. Now the minimum value, we want them to align. So the minimum distance should be 0. And the maximum, since the total length of the thread is 15, and we want the nut to be somewhere here at the end point here. The width of the nut is 2. So 15 minus 2 is 13. So the maximum distance should be 13 millimeters. Okay. So we can now click on the nut and then rotate it. You can see when it gets to this limit distance, it doesn't move again, and then it will come down. When it gets to this limit distance, it will not move again. So yeah, that's how to model the J-bolts and the hexagonal nuts and give them the screw motion so that the hexagonal nut moves only across the length of the thread. Thanks for watching. I hope this tutorial helped you out. If it did, make sure you are subscribed, like this video and share it, and I'll see you in the next tutorial.